This is the conference Blockchain Connect 2020. I'm happy to be here. My name is Sebastian Wain. I am the co-founder of CoinFabrik, which is a company that is focused on security auditing, research and development in the cryptocurrency field. We have done more than 100 projects since 2014. And here in this presentation, we will give an overview about blockchain security audits and how is the approach, okay, in this space, which is obviously it has a lot of issues in the aspect of security. So basically, this is like a blockchain application architecture and security issues that are presented there. What are the most common blockchain security issues detected in security audits? Well, the landscape of security issues is not only revealed by security auditors and researchers, but also by hackers. What makes security audits different in the blockchain space than in other kind of applications is that blockchain applications generally involve money. So a security issue could lead to funds being stolen or becoming inaccessible. Let's start by looking at these components, at the components of the blockchain stack and related known issues. It is important to keep in mind that while known issues serve as a guide, every application is different, so unknown security issues will continue to appear. Okay, this is like a constant fight for searching for new vulnerabilities, okay, and trying to enforce and protect the system. So most audits are currently focused on Ethereum, on the Ethereum decentralized applications, because Ethereum and its ecosystem are so popular among developers and users. Unlike Bitcoin, Ethereum provides a way to create decentralized applications. In that sense, Bitcoin is more limited. This makes Ethereum more complex and harder to protect than Bitcoin. The Ethereum-related audits and attacks are more now and since Ethereum was born, are more widely publicized than those involving in other blockchains platforms. This is because obviously there are a lot of assets that are used in Ethereum, comparing it to other blockchains. So this is a typical, what you see is a typical blockchain technology architecture. The layer one is the blockchain technology itself. The Bitcoin, Ethereum, and other blockchain software is here. There are thousands of different blockchain technologies, some of them with great variations. All blockchains have a consensus protocol and a global state database, but not all blockchains embed the capability to create decentralized applications. Since layer one is slow, there is another layer which is called layer two, which incorporates decentralized components which accelerate the performance, basically. One example is using payment channels to accelerate financial transactions. In general, like cryptocurrencies or blockchains like Ethereum or Bitcoin, they have a very small amount of transaction per second, so you need to add some new functionality in another layer. In some blockchain platforms, we can deploy decentralized applications using smart contracts. Now, more than 2 million smart contracts have been deployed in Ethereum alone. And in October, they contain a total of about $12 billion. So this makes Ethereum the primary cybersecurity arena, where the fight is happening every day, every second, and 24 hours a day, because basically this is global and it's not like a market where you have a specific time frame for operating. So most applications use centralized middleware to simplify the process of interacting with a blockchain. For example, some software services that is in the column of the middleware, some software services enable us to find transaction information more quickly, because the blockchain itself, like Bitcoin, Ethereum, they don't provide a way to access this information fast. Then we have oracles. The oracles feed decentralized applications with external information, because the blockchain only knows about the truth that is happening in the blockchain protocol, okay? But not, they don't know what's the price rate, for example, of Bitcoin versus the dollar, okay? Or the reais in the case of Brazil. So a smart contract cannot know the price of a crypto asset in a fiat currency without relying on external information. And then we have custody systems, which protects assets or identities on applications like cryptocurrency exchange. Then we have centralized applications that include many exchanges and wallets. In many of the most popular exchanges where you exchange one currency by the other are centralized, okay, not decentralized, even if they use a decentralized infrastructure, that is the layer 1 or the layer 2. And we have centralized, and finally, in the case of the end user, the user interface is always centralized, in the sense that when we have, for example, a wallet in our mobile phone, well, that application is running inside our hardware, okay? It's not running into different devices, okay? And this happens with the user interface. And sometimes centralized custody is optional, so you can choose between using the custody of an exchange, okay, or using your own custody, okay? This is like, sometimes it's a decision that you can take, and sometimes it's a decision that some service can give you. So now I would like to discuss some of the security issues that I have found for specific components. At the layer 1, typical problems are, for example, the breaking consensus assumptions and double spend attacks. Like the blockchains run on a certain kind of assumptions that supposedly they cannot break in, but sometimes they cannot break, but sometimes it happens. For example, last week, an important blockchain, which is called Green, okay, it's a blockchain oriented to privacy, okay, to sending transaction, to sending secret transaction between peers, suffer a 51% attack, which means that the consensus assumptions were broken, okay? What happened in that case, when you break this consensus, is that the actors that obtain this 51% attack can use their money more than once. It's like if you have, imagine that you have $10,000 or $1,000, where you can convert that those $1,000 in infinite money, okay? Because you can send the same amount of money for several transactions, okay? And another popular blockchain that is Ethereum Classic suffer multiple 51% attacks. So what we can think about this is that if some popular blockchain technologies are having these issues, well, it seems like if we count that there are thousands of blockchain technology, well, these issues can be found in many others. Okay, and then we have other kind of issues, like for example, denial of service. Okay, there was, for example, an error in parity. Parity is an implementation of Ethereum where you can send specific messages to the nodes, and the nodes stop syncing. Okay, so you stop. What you make is like make denial of service over the network. And then we have layer 2. In the layer 2, there are like, this is something relatively new and not so much scrutinized, okay, like the layer 1, but there were bad cryptographic implementations, in the sense that software that doesn't implement cryptography in a proper way, okay, and there is a way you think that your information is encrypted, but maybe it's not encrypted, or someone else can replay, okay, a payment inside these networks. There were attacks based on loss of funds, where you enter into this network with some money, and at the end, when you are out of these layer 2 networks, you lose your money. And privacy issue, okay? A privacy issue it means like the information and the actions that you are using with this layer 2 can be discovered by other parties. In the case of middleware, okay, software that is in general centralized, we have in general denial of service. It's like, because, for example, these days there was a popular middleware service which is called Infura. Okay, we don't think that there is no information that was attacked, but it doesn't work. Okay, and this specific blockchain service provides a lot of information for other software. So once it is not working anymore, like there are a lot of other services that cannot work, and for example, exchanges. Okay, exchanges where people have money and they want to exchange between one rate and the other. Well, okay, because this service was down, the other services cannot work. And we have other kind of attack, which is inaccurate data, because beyond the protection that a blockchain provides being decentralized, if we access the blockchain through a middleware, okay, which is centralized, if the middleware is compromised, well, okay, the information that we are receiving from the middleware is not accurate, okay? And we have a big point of failures in the case of middleware that are the oracles, okay? Many smart contracts need this external information, for example, mainly information about cryptocurrency rates, okay? And if these oracles are compromised, okay, we can manipulate the price, okay? And we need to think that, for example, in exchanges or decentralized exchanges, there are orders that are executed under certain conditions. For example, if the price of Bitcoin goes below certain number. So if you manipulate the oracle, what you are doing is basically firing a lot of orders, okay, and maybe moving the market. Okay, that's a potential problem with this. So they are a single point of failure. And there are other kind of oracles that are decentralized, okay, where we receive information from many parties, okay, so we don't have a single point of failure, But the complexity there is how to know that all the people in a decentralized network that is feeding us with information, okay, which are the good and which are the bad guys, basically. Okay, so that's a complexity with Oracle itself. And then we have obviously the custody. Okay, in general, in blockchain exchange that are centralized, the custody is handled by them. Just in 2020, there were $2 billion stolen. Okay, this is what we know. Okay, but probably this is more money because many security incidents are not reported. Okay, then we have the internal security risks about employees, internal rogue employees that are basically that can access information or the keys, okay, here the private keys that are there, and they use that. The custody system does not need to be hacked from the outside, but just need help from the inside. Okay, and then we have security process, okay, validation, because in general this custody system is not just that they sign transaction to sending, I don't know, to sending a payment from A to B, from the user A to the user B. Okay, there is a process. It's like there is a plan. Like once the transaction is approved, it's handled by once the transaction is approved, it's handled by a workflow. Okay, maybe we need multiple signatures. Okay, security signatures to have this payment to pass through. In the case of centralized applications, one related to custody is about funds handled by third parties. Okay, another very important issue is front running. For example, when we connect to an exchange, the one who sees all the information is the exchange before they see all the transactions that are happening, even before they are executed and before they are put into the system. So they have more information than the normal users to take a decision about how to invest or not in a certain cryptocurrency. Then we have obviously the leaked data. They have a lot of data from users, and if they are hacked, this data can be exposed. And we have the problem with fake sites, because we access, for example, the internet via DNS, via domain name service on internet. If a site is hacked and another site is put in place of that, well, we are accessing the wrong site or the site with fake information. We have topics related to UI, the user experience in the end users. Like, for example, there are extensions, browser extensions that handles the private keys. And sometimes there are applications that store the private keys in the browser and sometimes let them unencrypted. So the browser is one point of failure for the security. So that's about the user interface. And the custody, this is the case of custody in the end user. This is what's called non-custodial, in the sense that you don't base your custody in third parties, but you do it by yourself, storing it in your computer, in your browser extension, or in a hardware wallet. Okay. And one, there are wallet vulnerabilities, like wallets that they don't store the information about your keys in an encrypted way. There are also issues with hardware wallets, where you have a hardware wallets that store in a separate device your keys, but there are ways to get the keys outside your hardware wallet. And then there is the thing about the unprotected private keys, that is how you how you store, for example, backups of your private keys. And there is something interesting in this context, because, for example, there are some hardware initiatives by Intel or by other chip manufacturers where you can store secrets in the computer chip, okay? But people or researchers mainly found ways to even get those keys from your chip, okay? And there were other kind of attacks where you have, for example, you are using a virtual machine in a service like a cloud service like Amazon or Google Cloud, and even if you are not the owner, if you are one of the users of that virtual machine, you can steal some secrets for the machine. So it's not it's something that there are a lot of things that we need to take into account. And we have the decentralized apps itself. We have put a brief summary of some of the attacks, but indeed there are like hundreds of attacks to decentralized apps. Typical problems are access controls, decentralized apps that don't enforce security controls. There are issues about governance, because there are decentralized apps where people can vote and decide over funds or over the smart contract behavior, okay? And this voting system has issues. There are arithmetic issues, bad calculations about numbers, okay? And again, because most smart contracts deal with money, if we have a bad calculation, we have a big issue. We have specific things about on-chain oracles. These are oracles that try to infer prices, okay, based on how people buy and sell cryptocurrencies, but inside the decentralized application. Then we have denial of service, way to stop these smart contracts or make them to not work. And one issue is like, one big issue that is structural is the integration between different decentralized applications, okay? Because now it's not like 1 year ago, these smart contracts were isolated, okay? They were not connecting one smart contract with another from a third party. So now we have a chain of connection between smart contracts, and that increased the risk a lot. So there is one question here. Just cryptocurrency in this case. So Teo Marquez sending me information from Enrique Luis. He says more dApps are done like hybrid format if they don't use cryptocurrency. In this case, beyond the business security data, have one other parameters of security to maintain private networking safe. Let me try to understand the question. Can you, Enrique, add more information about your question? Because I don't think I understand the question clearly. So I will continue to the next slides, and Enrique, please try to expand a little bit more your question. So, what are the security auditing practices? Okay, because what we show was just a summary of different issues in different components. Okay, so well, there are many security auditing practices to make these applications secure. One is the automatic source code analysis, where there are many tools that you can run over your code to discover some well-known security issues. Okay, this is currently used more as to follow some checklist, but these automatic source code analysis tools are not accurate and they don't work. They cannot find really difficult security issues. Okay, it's good to run them because maybe they find something that is so obvious, and you have developers that haven't paid attention to the security issues. Okay, they were focused mainly on the development side, but it's just something that you do, and in general, you don't discover big issues doing automatic source code analysis. So then you have the other process that is the manual source code review, and this is where auditors look at the code. Okay, they do what is called a static code analysis. It means like you don't need to run the code for the manual source code review. In general, like you go to the source code and try to find issues there. Okay, looking at the code, reading the code. Okay, and maybe doing some tests. Okay, but mainly reading the code. And then we have the dynamic security testing, which can be combined with the manual source code review, which is running the actual code, and trying the code with different hypotheses. Okay, and trying to obviously to break like a hacker the system. Okay, then we have black box penetration testing, which is an activity that is without knowing the source code or without knowing the infrastructure where the application is running. What you try is like to hack the system with less information. Personally, this is my opinion, okay, and mainly in the blockchain space, because security audits are in general are of 2 weeks, 3 weeks, 4 weeks, 2 months is a very long security audit in general. Maybe you waste your time if you go through the black box penetration testing, okay? Because you know less about the system, and maybe you have some findings in the end that once you have this information from the beginning, you can take advantage to find issues there, basically. And we have another kind of analysis that is relatively new, that is the financial analysis, because maybe the code itself doesn't have a security issue, but the financial model and the assumptions, the financial assumptions are not correct, okay? And you need to analyze it with equations, okay? Instead of looking at the code. It's like you see the code, but at the end you formalize it in a mathematical way, okay? And try to find issues with the funds there. And then we have a formal verification, which is you can have you can have a formal specification about what you want to do, and then you write code based on that formal verification. But maybe the code is not showing at full this formal verification. It's like the code, the smart contract, for example, doesn't follow the original specification. We have structural analysis, which is analyzing not only the smart contract in isolation or the application in isolation, but connected with other smart contracts or other components. We have cryptographic correctness, which is seeing if cryptography is used properly, because it's not like cryptography is not you cannot use cryptography just using the cryptographic functions for encrypting or decrypting. The way that you use it can expose you to risks. And then we have a reverse engineering when you don't have the source code, you can obtain the source code based on the binary of the code. So in this short time, I will talk briefly. You can see more security audits in our webpage or the public ones. Here is like one idea is like one is the money on chain security audit. Money on chain is a stable coin. Okay, we did several audits for them. This is a stable coin that is runs in a sidechain over Bitcoin that is called RSK. And in this case, we discover issues related to denial of service, okay, and the potential loss of funds, okay. And then I want to mention another audit that is a financial audit, okay, where we study a system that uses stake, okay, to see if the financial model follow the strategy of the economic specifications. So this is the presentation. Thank you. I have a comment. I think I have maybe 1 minute for answering some question. It's like one is I don't understand the question. It's like the security needs to fix in the side of public. In the case of private blockchain, the security is restricted in business network. Okay, this is a good question. This is in a private blockchain. Okay, the issues are one restricted to the network where the private blockchain runs. Okay, but also can be issues related to the private blockchain technology itself. For example, there are many organizations that use just a few nodes to run a private blockchain, and there you can have like a consensus issues, okay, that the ones that we presented for the public blockchains, okay. So I think we run out of time, and you can contact me at CoinFabrik if you have more questions or any need related to security audit. I hope it was useful as a summary of this subject. Bye.